they both use heat on the ground. Yeah, that's fine. Okay, so basically for geothermal cooling to start, so this is the home. Let's say like you're in the middle of summer in North Carolina, there's a lot of hot air just circulating around your house. Basically what happens is there's like a pump system that looks kind of like this, where the air goes through a heat exchanger, and if like the heat exchanger is kind of like a car radiator, that's like the most common type. But basically there's like this kind of tube system where the air can go in, and there's like this liquid that surrounds it so that like the air can heat the liquid without actually touching it. And so the hot air will circulate into this cold liquid. It could be water, it could be a refrigerant, but it goes through this like heat exchanger, which is right here.
Yeah, this is
and so the hot liquid will go down to the ground where it's like kind of this constant temperature of 55 degrees. So because when something is hot and it meets something that doesn't have heat, it tries to heat that thing up. Since the ground is going to be cooler than the liquid that's being used, it's going to try all the heat's going to leave because it's trying to heat the entire world, like all the ground. So obviously now this lacks heat, so it's cold, and it'll go back up, go back through the heat exchanger where it's converted back into air, and then there's like an indoor pump, like fan system that goes and circulates the air throughout the house.
But Charlotte, can this also work the other way around?
Oh my God, Eleanor, I'm glad you asked. Okay, so which I decided. So the same thing can happen in reverse, where you take the cold air and it goes to the ground where it's warmer, and then it circulates back up. And the pump, like this part, it does require some electricity, so it's like not 100% run by itself. Like it does require a supplement for energy, for electricity. It does say energy. It does require like an electrical supplement to function, but it's much more efficient than just using electricity to heat and cool in general.
Okay, and so just for like some quick pros and cons, one of the pros of this is that it doesn't rely on like weather or like the sunlight. It's something that's always going to be constant because the ground always has a constant temperature of 55 degrees. For a con, it's kind of expensive initially, but it's going to save you a lot of energy in the long run because you're not using electricity to heat your house. You're using heat that's already in the ground. That's something that's constant.
Yeah, and the winter as well.
Oh yeah, there's the most companies that do set this up have like a warranty for 50 years. So if it does break, some companies will pay for it, and it's kind of hard to repair since the pipes are underground. There's like not really a way to access them, but the materials are going to be durable to kind of. Oh well, like during the winter, there's of course like you want your house to be more than 55 degrees. So there's like this whole physics thing that goes on. I can't really explain it that well, but yeah, it just takes it and heats it back up, and then it circulates through the fan system. So we're going to do a little demonstration. We need 4 volunteers.
All right, 4 people. Molly, I really think that James wants to participate in our demonstration.
Okay,
And
we need 2 more.
I also really think that Katie would like to participate, and I think that Thomas would really like to participate. So let's do it. So
We need.
Okay.
So we have.
So-
This is going to be the house over by the desk,
Molly, you're gonna be the house.
and then over by the.
James, you're gonna be underground. So
Yeah,
you
you're
go
going to
stand
go
by
over
the
by
light.
the lettuce, and then Katie and Thomas, you're going to be kind of in the middle, and you guys are the heat pump industry.
Yeah,
Well,
somebody's gonna
actually, Katie, you are gonna be the heat pump exchanger, so you stand right here.
Okay.
Okay? And Thomas, you are going to be our traveler. And so you,
Wait, no, give it to James. Yeah, give it to James.
no, but she's the one that has the child to pick it up.
Yeah.
Cool. Fine. James, here you go.
Okay. So Thomas is starting out as hot air. So he's going to hold this red square, and he's in the home. So where do you think you're going to go? Yes.
Yeah, so this is our pump. So this is the hot air that's in the house during summer because North Carolina gets hot. So go through those pipes to get underground.
So you're going to go through Katie's, I called you Katie. Katie's heat exchanger. So now Katie is this liquid. No.
Oh my
Katie's. Yeah.
Okay, so basically, Thomas has gone through the house, which has hot air, and he goes to Katie's heat exchanger. He gives Katie the heat. No, he doesn't. He gives.
Because Katie's like a liquid. Katie's the refrigerant that needs to be heated up because you can't take air to the underground.
Okay, so then Katie, you are now gonna go to James. And you're gonna give James your hot air and take his cold air. And James is gonna now attempt to cool all of the earth. But because he is one tiny little bit of heat comparatively, he is just gonna kind of fail.
He's gonna dissipate.
Yeah. And so now Katie is going to give Thomas the cold because she has now cooled Thomas. Thomas is then going to walk back to the house, back to Molly, and have cold air. And when you look at this as a repeated cycle, by now Molly will also have hot air again, and Thomas can take another. So as soon as that air is cold, it goes back into the house. And there's no such thing as cold. It's only the absence of heat. And so Thomas is going to have his cold air, in which all of the hot air that is now in Molly is going to try and heat that back up. So all of the heat will be attracted to this cold, which will then be pulled into the system, and it creates this loop. Does that make sense? Does someone, also, let's give them a hand for being a demonstration. Does someone want to explain how 4 classmates holding this sheet of paper actually relates to the system? And just go back through the system. Derek.
So you start with a house with warm air in it, and that warm air is brought underground where it dissipates its heat and becomes cool air, and then it goes back into the house. And that's just kind of like a cycle that repeats to cool the house.
Remember that it's like a liquid that goes through, so it's not actually the air. It goes through the heat exchanger where it heats up this liquid, and then it goes down underground and
Yeah.
transfers.
So now questions. So Molly, what was your question?
What is it, water or what is it?
So it's a mix of water and a environmentally safe kind of antifreeze, and it's going to go through because like the air is going to cool the cold liquid is going to cool the air that goes back.
Does this have the same issues as geothermal electrical generation? Is it, or because like, can it only occur in some places that have this specific like magma close to the surface, or can it work with any?
No, because it doesn't. It's like not going down far enough. So the geothermal electrical, I'm pretty sure, like it goes down really far into the earth. This is just like like kind of short, small system. So it's like mostly feasible in homes and like buildings and stuff because like you don't need to go down that far. You don't need to drill that far for
We
it.
had
You
some-
just like it's just within like the 50 feet.
Yeah, and we have like some pictures of what
Yeah.
it would actually look like. But yeah, the kind of spot that they dig into the ground isn't that deep. And so
Well, yeah, and like the other thing is like with the for electricity, you're drilling down to the magma to create steam so that it'll turn. And obviously 55 degrees isn't enough to create steam. So you're just looking at the 55 degrees is the residual heat in the ground from the magma rather than drilling down to the magma. You just have to drill down until you get to that constant temperature, 55. So it works pretty much anywhere. Because the ground has this universal temperature, no matter what the climate is above the ground. So it actually works out pretty nicely.
Do you have any other questions?
Katie.
With heating, so so with the cooling, it takes the hot air and takes it to the ground and so then for heating, it takes the heat from the ground and brings it to the home. So like, there's this whole
It's
kind
like
of
a combustion
it's like
almost.
He told us not to explain it because
Yeah, it's physics, but the important thing to know is that it's not heating it the way that we would think of like pumping hot air from like an electric heater in. It's heating it, it's like taking the 55 degrees and doing something,
Physics.
yeah,
Physicsy.
physicsy
doing
to
something
it.
with physics.
That
But
makes it hotter than 55.
kind of just like the way you remember it. It's like for cooling, it takes the heat from the home to the ground, and for heating, it takes the heat from the ground to the home. If that makes sense.